correlation is a measure of the strength of the relationship between two variables. Some examples are below. For instance, first of all, let me just explain, is there a correlation between height and weight? You know what I mean? Now, I think there's some correlation, but not perfectly correlated, because the taller someone is, it's not necessarily that they'll weigh more. They could be very, very thin. Do you know what I mean? So here, Y increases as X increases, therefore they have a positive correlation. So overall, it's sort of the linear relationship is going in that direction. If one increases as the other increases, for the most part, roughly, as height increases, weight increases. Is that correct? For the most part, but not always. Now for the next one, Y decreases as X increases. Therefore, there's a negative correlation, so it's going downwards from left to right. The hotter it gets, the less soup is sold. Yeah, that makes sense. Everything okay? So that's got an opposite relationship or a negative correlation. Here there's just random. There is no pattern between X and Y, therefore there is no correlation. So you just got random dots with no, clear up or downward thing. So what's completely random? The correlation is high or strong if the points are close together. For instance, if the dots are really in a really closely straight line, can you see that? They look like they're in a really close straight line. That's a high or strong correlation. It's weaker if it's it's going upwards, but they're further apart. Do you know what I mean? Then it's perfect if they're perfectly on a straight line. That's perfect. Okay? So using those, describe the correlation in the graphs below using words such as positive or negative, weak, moderate, or strong. What do you think about A? Positive? Yep, positive. I agree with positive. And what other word would we use? Perfect or strong? They didn't list perfect in the question, but we probably should do perfect. Oh, it's here, but it's not in the question. But you're right, it is perfect. So let's put that. Positive, perfect, or perfect, positive, whatever you want to call it. Okay, take a moment. What about B? And you might think of B as in relation to the other graphs. Negative, definitely. And another? Moderate, I like moderate. Or even strong. I wouldn't strongly disagree. Okay, let's think about C. No, maybe almost no correlation. Yeah, I think that's probably better than weak. It's just random. What do you think about D? And given that we've called B moderate, what would you say for D? And, yes, positive and weak. You could write them the other way around. Weak, positive, or whatever. Okay, E. Strong or even perfect, I wouldn't argue. And negative, yeah. Strong negative correlation. F. Weak. Negative again, oops. Weak, negative. Beautiful. All right, excellent. Now here's some actual examples, and we're going to talk about if we think they have a positive, negative correlation, or even no correlation at all. So here's some actual examples that we couldn't think of before. Height and weight of a person. So in other words, as height increases, we always say the first one increases. What happens with weight? In generally, we'd expect it to increase, but it's not a perfect correlation, is it? There's going to be some contradictions to that. So we would say generally, though, it's a positive correlation. Salary level and shoe size. No correlation. There's no relationship between them. price of a car and the number of cars sold. So basically think of this. As the price gets bigger, less cars get sold probably. Again, not a perfect correlation, but generally I would say that. Because I think of the extreme. A $2 million car, I'm guessing not many of them are on the roads. You know what I mean? I'm guessing not many people buy them. So negative. Effort studying for an exam and exam mark. So the more you study, the higher your mark. But is it a perfect correlation? No, you might study too much and burn out. So it's nothing, none of these are perfect, but generally speaking. So we think it's a positive. Is this all making sense, girls? Now, outliers. Using the diagram below, how would you describe an outlier? Now, usually we're used to this is like on a dot plot. You'd have all these dots and then one over here, and that would be the outlier. But it works a little differently on this kind of thing when it's two variables. This here looks like an outlier because it's away from the group, but what we're actually looking at is, does it follow the trend? And I would say that that one there that I just circled does follow the negative trend. Does that make sense? So therefore it's not an outlier. But over here, this is an outlier because it doesn't follow the negative trend. Correlations and causality. If two variables have a correlation, it does not necessarily mean that a change in one causes a change in the other. For example, a person's salary and how much they spend generally have a high correlation. But a change in salary does not necessarily cause a change in spending. Does that make sense? For instance, if I get a bit of a pay cut, I might be in denial and I might continue my habits and spending the way I spend. Do you know what I mean? Smarter people might cut their spending. Or for instance, if I get a pay rise, that doesn't necessarily mean I'll spend more. But yeah, it doesn't cause it. There might be a relationship, but it doesn't cause it. So each of the following pairs of variables do have a correlation, either positive or negative. But identify which pairs have a causal relationship. Amount of traffic and driving time to school. So as the traffic increases, does that have an effect of the time it takes to get to school? I would say yeah. Generally, yes. So I think that's causal. Number of male babies and number of female babies born per week. So as the number of male babies increase, does that necessarily affect the number of female babies? I don't think so. There's probably a relationship in that generally it's 50-50, but it doesn't necessarily push one either way, so not causal. Daily price of petrol and amount of petrol sold. Look, some of these are debatable, okay? So what do you think? I guess it's hard because you're not driving cars yet, but what do you think? Well, some of you are. You think it is causal, yeah? Anyone else? Yep, okay, cool, that's right, causal. I know some people just don't even look at the price and they just go, I need petrol, I'm going to do it. Number of mobile phones and number of TVs per household. So as the mobile phones in a household increase, would the TVs increase? Would it push the TVs up? No. But generally, if there are, they're saying it has correlation, in which case, if there's lots of mobile phones in a household, there's probably lots of TVs in the sense that maybe they're wealthier, maybe there's lots of people. But one doesn't necessarily push up the other. Do you see the difference? So I would say not causal for that as well. Before, we were just looking at graphs, weren't we? And saying, oh yeah, that looks like a strong relationship. Oh, that looks like a weak relationship. But now, this thing called the correlation coefficient is actually going to give us a number for that relationship. And so then we'll be able to compare things easily, even if they look the same to the naked eye. Do you know what I mean? So here, the correlation coefficient, or R, is a number between -1 and 1 that measures correlation. The sign of R indicates the direction of correlation. So in this region here, we've got a negative correlation. So we're probably going, like the dots are going downwards. Does that make sense? It's like a negative correlation. But on the other side, we've got a positive correlation. So the dots are probably going upwards that way. Does that make some sense there? So at -1, that's the perfect negative correlation. So we're at a perfect line going down. But a strong correlation is kind of like this. And then a weak correlation is more spread out. And then no correlation, that's when we're like anywhere. Do you know what I mean? And so these are the kind of numbers that might go with them. So like -0.8 is quite a strong negative correlation. But -0.2 is a weak negative correlation. It might almost look like no correlation. On the other side, a positive correlation with 0.2 is quite spread out, but still positive. Then we get stronger and stronger until a perfect positive correlation at +1. Is it making some sense? So now we just got a number with it. So here's a rough graph of what they would kind of look like. So R is 1, as you can see, positive perfect correlation, and then it just changes. Take a moment maybe and read through them, compare the values it's given to the diagrams. Really, this is to give you a guide. It's not like exact. Like for instance, if your graph looks something like this, you don't have to be at 0.87. Like it's a bit overly specific here. You know what I mean? It's just rough. Okay, now I've given you a few numbers. I want you to sketch a scatter plot, which dots, where the variables have a correlation coefficient of this. So we've got -0.8. Can you describe it to me? How should I draw my dots? Downwards? Yep. Little bit gap, so like not a perfect line. So maybe something like this, maybe even closer, I don't know. Something like that. Okay, next one, R is 1. So these are values of R. Perfect straight line. Yep. So my dots should be in some kind of perfect straight line.
When it says perfect straight line, is that when it's x equals y?
Kind of, yeah, it would lie on the line x equals y. Though technically it could be up here. Just these dots. So it may not be perfectly from 0, 0. 0.4. Upwards but weak, so a little bit more. You want to be able to see the positive trend, but it's pretty weak. We will find the value of R using technology in this course. That's the good news. A chemical fertilizer company wishes to determine the extent of correlation between the quantity of compound X used and lawn growth per day. So we're really just comparing how much compound X with the lawn growth. Those two variables there. Find and interpret the correlation coefficient between the two variables. Using our calculator, R was, 0.989? 9689, or in other words, 969. Okay, thank you, sorry. So we got 969 girls. Okay, that's just a number. What does that tell us?
Strong correlation.
Exactly, just strong correlation. Positive, even very strong positive correlation between the two variables. So either one, strong positive is fine. So therefore, there is a strong positive correlation between compound X and lawn growth. So girls, what does that mean? Like, what does that tell you? If you need a lot of lawn growth, what does that generally tell you? Use more compound X to get more lawn growth. The weights of a group of adults along with their max running speed are recorded below. Find R for the data. Sorry, negative 0.8?
813
813, excellent. Okay, so what does that tell us, girls? Strong negative correlation between weight and maximum speed. So yes, write that down. I'll just write it down. But in just normal words, what does that tell you? Like, what would you tell someone that wants to really get the best speed they can? What would you tell them from that? The more you weigh, the slower you are. Therefore,